All right. Hey. Hello and welcome to Kerbal Space Program 1.8.1. Anyway, once again, I call myself PACE X. That's Pilot in Space Training Experience. What I am, or how I view myself, is like Tim. I'm an everyday astronaut, but I haven't almost killed myself in the process. I don't risk. I do computer edutainment, simulation programming, and what I'm trying to demonstrate with YouTube videos is that these concepts are not out of the realm of common everyday man, including children ages 7 to 11. That's basically what this explanation is based towards. Anyway, sometimes it's about becoming familiar with the vocabulary. You have to understand the concepts behind the vocabulary, some ideas, the holes in the ideas. It's called falsifiable. It means we're going to try to prove it wrong. It's the whole basis of science, actually, is getting an idea, thinking you know what's right, and then going down the path to prove what you think is right wrong. And then if you can't prove yourself wrong, you might be onto something. It's kind of like this deconstruction, backwards way of thinking. So deconstruction is when you take something and you take it apart and see how it works. And then after that, what we can do is build a new one based on what we learned from disassembly. Anyway, the power of disassembly. That sounds like science fiction. Have some robot going around destroying things so it can get better, and somehow having a great misunderstanding with the people that feel threatened by its perceived negativity, but it's just fulfilling its program to achieve a positive direction. I mean, go ahead and think about that. The misunderstood robot. Oh, well, it's been done before, right? Anyway, so what we're doing is our active mission, and we had two, but I've already done one, okay? And this is it. Now, the primary difference between this one and that one is on that one that's already done and completed, I had to travel out the 270-degree direction or go opposite of what I've shown you. In this case, I'm going to have to do the same thing. So the only thing about going the opposite, you can go the 270 direction to get into near Earth orbit, but you're spinning against the planet now. So you become less efficient, you require more gas, everything's a lot harder work, and you're going about it backwards. I think maybe for kicks, I might put two spaceships in orbit, opposite directions, and then send them both to the moon and see what happens. Now, that's another point. We haven't looked into that. So when you go to the moon, you can actually do it one of two ways. You can go into orbit spinning clockwise or counterclockwise. And then if you want to go north to south off the moon, that's a whole nother trick. What you need to do is come in at kind of a sharp angle, and then you're going to have to correct, because that's quite a bit of actually quite a bit of fuel to do a complete 90-degree twist. But anyway, we're talking about the future now, so let's go ahead and look. I've already built a satellite system, and I just call it SAT. So I'm going to change the name here to SAT 090. Alright, now the other SAT, we're going to change it later to 270 now. What I want us to look at, and this is the problem, and it's also good practice to learn what we call finite control and understand and appreciate what stability and assist control does for you, because this rocket has none. We're going to be flying it by the seat of our pants, literally. We're also not going to have any trajectory information because we won't have a Kerbal on board to extrapolate that data and convert it. So we're going to have to do a lot of stuff manually. So as we have progressed, now we're going to launch an unmanned craft, and we're going to be limited in our control and our scope. So we kind of need to be on the ball, and we're going to be, it's going to be a lot of manual adjustment all the way, and it's frustrating for me. So let me get my game face on. Oh, I saw that cool thing. It was a high school finals. You know that New Zealand thing where they go, ooh, ooh, and they start stomping with their feet. Ooh, la, la, ooh, la, ah. I don't know if you've ever seen it, but it's like a traditional New Zealand warrior dance. I've seen it other time at young boys' school. It was an honor of respect for someone that was leaving, and they did it in this massive group in suits, and it was kind of subdued and a little closer to the shoulder. It wasn't the big dance in costumes. But that's the only time I'd seen that before. But then I saw the national high school finals of this art. And what happened in this one was women came in and did it. And it was really cool. It was real soft and subdued and was more like told a story. It wasn't that big crazy warrior, prepare yourself for a fight, insane big guys, you know. That's the one that looks good on camera, but man, there's so much more to it. And I guess that's what we are here, you know. If you're crazy enough to fly a rocket, then you're a warrior for sure, for sure. Very interesting cultural display. So, moving on from the 7-minute mark, which, you know, we always talk about a little something that has nothing to do with something, but then it might come back to something in the long run. And it's not really lack of focus, it's more of a supporting sub-focus. Anyway, sometimes people think you're scatterbrained, but if they don't have patience and a contextual perspective of what you have, then they can't really hear what you're saying. So you actually have to know who you're talking about. Now, look, I pushed that, no stability control. All right, so I can see this is going to be a little daunting to have to hit the button twice. So let's go ahead and, man, maybe if I dump that on. Let's just go ahead. All right, we'll launch it. Now remember what I said, seat of the pants, so I might be busy working and not able to explain, and if I do start to explain too much, I can get to the point where I'm either overcorrecting or undercorrecting. So off we go. Now you notice if I push here, we don't get any telemetry, so that's one thing we've lost when we don't have men on board. We don't have stability control. Right now I'm just letting the thing do what it wants. I mean, why fight it? If I try to fight it, I might. It's going straight up. It's just got a little twist to it. So we're going to try to run out there. Now remember, when that runs out, we need to have gas in our other rocket. And I'm just going to put it where I think it needs to go in the future. Solid fuel is about to extinguish. It's out. Alright, my booster has cleared. Kill the gas. Kill the gas. Give the gas. Kill the gas. Give the gas. Kill the gas. Alright, I don't know if you can see what I'm doing, but I'm actually going to try to stop this in a roll. I'm going to stop the roll. I was trying to get some altitude, right? That's why I was killing and extinguishing the rocket. I was trying to punch myself a little bit. And what I need to do desperately now that I'm starting to get some control is find out where my apoapsis is. Oh, looky there. my kill the gas, punch the gas ended up putting us at a high level apoapsis. So as we're losing speed here, but I'm not going to concern myself with that, because when I get here on the pushing the wrong button, sorry. See, that's what happens sometimes in the demonstration. You get the other half of your brain isn't quite engaging. So the mouth and the actual action is different parts of the brain. And then the explanation is also with the part with the mouth, but the process that you're going through is in the other half of the brain. So you got to put both halves of the brain together. Now, I've got it set up pretty good. I'm going to gas it hard. All right, that's full throttle. I don't know if you can see it, but as we're pulling into that, I'm approaching my apoapsis like at a rate of speed that's all right, working. It's like Scully says, always fly the craft. And when you're trying to talk on the radio, if you're a pilot, craft operations and not hitting the ground comes before radio communications every time. They will wait. They understand, especially if they're hearing your voice and you're stressed. All right, now I'm in trouble because I'm at full throttle. Okay, I'll bring it back. All right, kill it. Kill it. Now, I need to calm down. I have 25 seconds. Calmly, calmly, calmly. Now my goal is 2250 for the first check. All right, good. So I'm going to give it some gas. And I'm going to try to get to 2250. I'm there. I stopped. All right. Now I'm going to back up and I'm going to look at the big picture. Looks like I'm at 77 and 43. I need to just give it a little gas. See, we're not flying with any stability control, so I'm having to drift through that. And it's also, it looks like 1.8. All right, good. Orbit above 70, but I'm in space. I can relax now. Okay, 1.8 has added this new feature. I have joysticks and controls that I'm really used to flying with, little precision dials for my throttle. It makes it feel more like a craft rather than hitting buttons on the keyboard. But 1.8 looks like they've upgraded somehow to where if you have an unmanned craft, they won't let you use your joystick controls. You have to use the keyboard inputs. I like it, but I don't like it. I don't like it because it's harder, but I do like it because it gives you a suspension of disbelief and an element that somehow unmanned is different than manned. And it's kind of a role-playing separation in your mind to make this feel more plausible, more real, more practical. There's a lot of real stuff about this, physics, everything else. The only thing that's not really real is the little green men. And I need to make sure I have my gas off completely. I saw a little plume when I came in. I don't know what's going on. Let's go look at my map and make sure. All right, 72, 79. We're in a pretty good orbit. Now, what I really should have done, and this is an afterthought, is attached a similar satellite program to this stage, like some control, separated here, and then I'd have two satellite systems, one low, one high, both delivered by one vehicle. And we may actually do that for if we need to create a polar satellite, a high-low. Or we'll send one to the moon, or we'll send one to the moon, and then the other one can go off to orbit the sun. We will design that though. So it's what I'm trying to do is to avoid space junk. Now the other thing I could have done is put a docking port on this and had some fuel, about 240 liquid fuel that would have been orbiting in space for someone to utilize or capture, and we're on a pretty good planular orbit. I need to take a quick break, so give me a second. I'll be right back. All right, so what I was talking about was not leaving space junk, and we'll do that in the future. So at the 16-minute mark, we are going to evaluate our position. And this is our goal. We're going to set target on the moon just to read how far off. We're 0.4 off. And it looks like this satellite and the moon are in dual planular. Would that be right? Or simoplanular? Anyway, they're in the same plane of existence, which this little indicator right here tells me that I am 0.4 degrees off on what we call my angular, and depending on where you are at in angular relationship to your target body, we would, in which direction you're traveling or where you're at in the circle, you're either in a moment of ascension or angular ascension or angular descension. Anyway, bunch of fancy words to say you're tilted. And that's measured right here in the ascending node and the descending node. So this is us. We're coming up on our periapsis. We're also coming up on an ascending node. So what I need to do is try to increase this orbit and also correct that node. I don't really know which would be easier first, so maybe we should just do a bit of both. So the first thing we need to do, oh no, okay, so this is a problem. We have no probe control because we have just lost radio contact. So let's go back here. This is bothersome for me. We knew it when we got into it though, so at least we're in a stable orbit. We're not going to crash. So we may have to do our correction about ascension and descension either later or on the ascending side, not the descending side. It's all a bunch of fancy words for this one or that one. And anyway, once you learn the words, they really don't mean anything fancy, but people who don't know the words hear it and go, oh my God, that guy, he's so smart. But anyway, the concepts really of physics. Oh, shoot, I got my radio back. All right, so while we have our radio back, let's go ahead and increase our signal strength by extending one antenna or extending two antennas. I also want to open my door. Open. And what that does is this gives me 4 points on a solar panel instead of 2. So it's most likely that no matter what's happening, I will charge my batteries, even if I'm out of control. All right, so let's see where we're at. We need to know where we are before we can understand where we're going. So we just passed a descending node, -4. Okay, that's the positive ascension mode or node, and we're already past it, so it really doesn't matter. We'll just do it later. But what we do want to do, you can hear the loud clicks because I have a mechanical keyboard. It's for simulators. It's much more responsive than your touchpad. Little, I don't know what you call them. They're different. There's a mechanical key. It's a distinct on and off. And then there's the, I think they call them touchpad sensors. They're like these little air bubbles. And when they come together, you can take a keyboard apart and see one. And then if you look at but mechanical keyboards have these different intensities and different strikes and how they respond. It's more like a piano. I'm old school. I used to use this mechanical thing where this bar came up and went bam, smacked into the paper like a printing press. A little typewriter ribbon, which is an ink strip, would raise up so the ink thing comes up and the arm comes out and just bam, and puts one letter on the paper. You know, people typing 45 words a minute on a mechanical is amazing. But then, you know, now on these keyboards now, with the touch sensitive glide, you get people doing, I don't even want to say. Anyway, what is it, 60, 80? I'm guessing. All right, so this is the orbital prograde node. And if we didn't have this at all, like that little indicator on our ball, we could still see the 90 and put it in the right spot. I mean, that indicator right there is something the computer is placing for us. If we had no computer and we just had a functioning navigation compass or high-tech, you know, pilot navigational, this gyroscopic indicator. All right, so what I want to do basically is I'm going to hammer this pretty hard. I might even run it halfway out of fuel. And I got to make sure I don't get too off the beaten path. So go ahead and shut it down like that. And then get this back up. Because look, it was getting off. And what we can do is check our node and see our node actually grew from 4 to 9. Which that's not too hard to put back, but it's also kind of easy to correct if you do it at the right moment and you're lucky enough. Oh boy, I did it then, didn't I? I just overshot that. Oh, now I got to bring it back. Sorry. All right, 8250921. All right, it's somewhere in between those two. Somewhere in between those two. And now our ascending node is a full 1.2. We are going to either worry about it or not. And how I would do that is just pull right up to it. Let's go ahead and warp here. And we're going to put it on what I call plus ascension. And if you know what a plus sign is, and you know the opposite is a minus sign, And we also say positive and negative. So this has no vortices, so that's the descending node or the negative. Let's go look at the positive or the plus or the ascending. It has a directional indicator vortices. That means that's in a positive direction right there. Usually it means up. The other one means down. This one means up. If we were parked next to a planet and I was doing this, I could show you that. What actually, you know, one's pointed towards the north, one's pointed towards the south. It's real easy. And that's where you get the D, the A and the D, you know, the alpha and the delta. I mean, it all comes from somewhere, and it all means something. And it's basically because we had the Greeks and the Romans battling out to see who's better, and we settled that neither yet both. And we created something called Western civilization. Of course, the opposite would be the Asian cultures and Indian cultures, and we call those Eastern. Sometimes you'll hear when the East meets the West. Okay, so as we're closing on this 1.2, and we've got a pretty good fixed position on that. I kind of got out of control using the gas a little too hard earlier. We just pushed that, and let's look at it again. And we just turned it into 0.7. So the closer we get, the more effect it'll have. Like, all right, so did I just go past? No, it's still +2. So we're going to forget about that. Figure we're pretty close. Remember, we were 4 when we started, and then we went out to 1.5 because we don't have stability control, so we're flying by the seat of our pants with objects in motion. It's not really easy, but it's good practice, because if you're flying with a scientist or an engineer 27-minute mark, then you will understand that this is how it flies until you get some type of computer autopilot simulation or stability control, like autopilot assist, computer stability. But the pilots have it in their natural ability through training and practice. They can control crafts that other people can't control. So if you get good at it like this, you really don't even need them. And then I'm going to get this lined up, and then I'm going to hit the nuts button. And that's the all throttle, all now. All right, that's pretty good. And I'm kind of trying to see if I can stabilize. See, the mechanical is real precise. The touch is kind of like grab and let go, and there's like a time ratio. The mechanical, the timing is based on your pressure. If you hold it down, it'll hold down, and if you go strike, it'll like give it a spark. So mechanical keyboard if you want to do